Hello, hello. Hope you're having a great day and welcome back. I'm Ashton. A lot of you know me as Argon Mining in Discord, Telegram, and on X. I help with business development at Igra and obviously have some other involvement in a handful of other projects in Kaspa ecosystem, from Nacho to Cat Foundation to Cat Bridge and so on and so forth. Today, I wanted to create a video and walk through how to set up an Igra Labs mainnet node. This is the new EVM L2 that's designed for both humans and agents alike to interact with the Kaspa ecosystem. So what we're going to do is essentially walk through three parts of how to set up and operate an Igra node. The first part is really just getting the core foundation of the node set up. This is referred to often as the backend profile. It includes a Kaspa node baked into it. So if you are choosing to run an Igra Labs full node on mainnet, you are also running a Kaspa node and contributing to the decentralization of the Kaspa network as well. This backend profile, the first part of our video, is really just the foundational setup that we need. And it does not include RPC services. This is a really important point because Igra Labs network is a based rollup and one of the first based rollups we've ever really seen in the wild. And a based rollup means that every single transaction that comes through the Igra network is actually sent to the L1, to Kaspa mainnet, for sequencing and confirmation by the Kaspa miners. This has a lot of security benefits and kind of performance improvements that we're not really going to discuss on the video, but it's really impressive. And I think these Igra Labs guys have done a really good job of creating an environment where we're contributing to our L1 through miner fees and increased transaction amounts without being parasitic, without taking fees away from those miners. So I digress a little bit, but the first part of this video is just setting up the core node, the backend profile, and it will not give you RPC services. And that's because every single transaction that comes through an Igra RPC has to be kind of repackaged or resent to the Kaspa L1. So you've actually got to have wallets on your node that can process Kaspa transactions. So full nodes can operate without RPC services just to give you local access to the data and the state of contracts and things like this in the Igra L2. Or you can turn on RPC services and either use those for your application or infrastructure, or even provide them as a service to others in kind of public RPC access style. So the first part of our video is just setting up the backend profile. The second part is going to be setting up the front end profile, or those RPC services. The last part of the video is focused on validating. So Igra Labs, because of the way Kaspa L1 works with pruning of nodes and the reorgs of transactions that are very normal on Kaspa, not a security concern, we need to have an attestation layer, which means that there's an Igra token that you can stake against your node and attest to transactions, essentially create a proof on the L2 of things that have come before your transaction. And this enables some light and ultralight nodes where these users that operate a light or ultralight node do not need to resync the entire chain history. They're able to get it in a much faster fashion, and they're not required to run a Kaspa archival node to enable this. So videos in three parts. Backend profile, the core Igra node, then turning on those RPC services so that you can actually use your node in MetaMask or Rabby or your dApp or whatever it is you're building. And then the last step will be how to attest and actually earn rewards, both in the form of ICAS and Igra token for staking and validating transactions and enabling better decentralization for your peers. So a little bit of housekeeping. On my screen, you see two separate windows. On the right, we've got my browser, which is just standard Chrome browser, and we're just going to use this to walk through the guide, to get some commands, easy copy and paste method, look at Igra documentation, things like that. On the left, I've got IDE, an integrated development environment. You might use VS Code or Cursor or Claude Code or many others out there, right? And you don't even have to use an IDE for this. You obviously can just use terminal on your local machine or SSH into your hosted machine, a VPS, and just use the terminal application to do the same thing. I like using an IDE because I get to see the files that are created. I can even look and review those files in the window. And it's got an integrated terminal where I can run all the commands just the same. So on the left-hand side, you've got my IDE. On the right-hand side, you've got my browser. And we're going to be flicking back and forth between these to get going. A little bit more housekeeping. Igra nodes essentially are kind of, in theory, equivalent to like a Kaspa archival node. A full node is going to keep the entire chain history on your machine, which means we've got some pretty high system requirements here. So you are going to need a machine with at least 32 gigs of RAM and at least 3 terabytes of SSD storage. Obviously, the attesters will enable light and ultralight nodes that have significantly lower system requirements. But here in this video, we're talking about running a full node where you can actually be an attester, stake your tokens, and fully participate, offer RPC services, and all of these things. So we're going to be using a large VPS that meets these system requirements. Now, it can be an ARM-based machine or an x86 or AMD 64 style machine in terms of CPU architecture, because all of this runs as Docker containers. So it doesn't really matter which CPU architecture your machine uses. You just have to make sure that you have all the dependencies installed. So on my machine that we are SSH'd into right now, I've got Ubuntu 24 installed, the latest version. And I've gone through some kind of like system cleanup and system prep, right? So running sudo apt update to get the latest packages, sudo apt upgrade to install those latest packages. And then I went through and installed some other things like Docker and Docker Compose, GitHub's package so that I can actually clone repos and interact that way, and things like this. One other thing that's important to note, because these Igra full nodes run a Kaspa node embedded, it's not exactly required, but it is recommended from me personally to install Rust on your system as well. So I've already done that here. So if you're following along with this guide, you should have a Linux-based VPS or local machine setup that meets those requirements, 32 gigs of RAM, 3 terabytes of storage. And you should have kind of prepped your machine by installing the latest packages, upgrading to those, installing Docker, Docker Compose, Rust, GitHub, SSL certificates, things like this. So we can jump in and get started. In my browser, I've just gone to the public Igra Labs documentation on Gitbook. You can't see my address bar here, so I've pasted in the link right here. It's just igra-labs.gitbook.io/igralabs-docs. And that'll take you to this page right here. And what we want to do is click on how to set up a node. From there, we see this linked or kind of embedded GitHub guide. And all we've got to do is click right into that. And this takes you to the kind of walkthrough guide of how to set up a node. And it gives you some of the system requirements, right? You're going to have Docker Engine and Docker Compose, need at least 32 gigs of RAM. As we said, at least 3 terabytes of SSD storage. And then you've got, SSH and Git requirements to actually pull down the repo that we need all the files for. In getting started, we see 3 different versions of the network. We're only focusing on Mainnet right now. Galleon testnet is up and running. You can run a testnet node if you like. I don't think it's in your best interest to set up a Galleon mainnet. This was this kind of temporary test mainnet environment just to make sure that everything worked well with Kaspa mainnet, and isn't a real mainnet. So ignore this one, kind of avoid it. It's really not a good use of your time to set it up right now, in my personal opinion. So we're going to focus on mainnet here. We click into mainnet, and all we really need to do is pull down the GitHub repo and then run this script. The Igra Labs team has done a really good job of making this pretty close to turnkey, so that it's really easy for you to set up a node. But the first thing we need to do is pull down that repo. So you can scroll down and try and use the manual commands here. But what I really want to do is just get the repo itself. So in another tab, I have the Igra Orchestra repo from Igra Labs in GitHub open. And all I want to do is clone it to my machine. So I'm going to go here to code, GitHub CLI. I'm going to grab that command right there. I'm going to go over to my IDE and just paste that command in. And it's gh GitHub repo clone Igra Labs / Igra Orchestra. So we hit enter on that, and it's going to pull down the entire repository from GitHub. And over on the left, we can now see that we have that whole repository. It's added everything right here. So now we can jump back to our browser and continue on with the setup. And the first step really is just grabbing this command, /scripts/ setup-mainnet.sh. And we're going to pop that into our terminal, and we'll follow along with the process that it makes. So you got to make sure you're in the right directory. I'm in my parent directory of Igra-mainnet. What I need to do is change directory, cd, to Igra Orchestra, which is not spelled correctly. There we go. And now I'm in that correct folder. Now I can go through and run that setup mainnet.sh script. And it looks like we are missing a package on here. So if you do see any of these things, if you're on Ubuntu like me, you can just grab that command and install it real quick. We'll say yes to install that. And I'll clear this out to clean up our terminal so it's easier to follow along. And now we can just run that mainnet script right here. There we go. So it's going to be a interactive script. You're going to be able to put in information as you go. And the first thing you want to put in is the name of your node. There is a dashboard where you can monitor your node's progress and make sure that it's synced and everything, so it's a little bit easier for you. This node ID is going to be used to identify which node is yours on that monitoring dashboard. So I'm setting up mine on behalf of the CAT Foundation. So I am just going to call it CAT. And we've now got our node name, which is mn-cat. And I have set up a domain in advance. So in my domain's DNS settings, I went in and I created an A record on the cat.foundation domain that was igra-node.cat.foundation. And that just pointed to the IP address of this server, this VPS. So I'm just going to pop that in like this, igra-node.cat.foundation, and hit enter. And then I need an email for the Let's Encrypt certificates. This is kind of a legal requirement in some areas and otherwise just best practice, so that if your SSL certificates are expiring, you can get an email and be told that that's happening. So I'm using just a generic mailbox that numerous people on the team have access to, so we're all aware. It's just legal@cat.foundation, and I'm going to hit enter. Now here, you want to create a password and save this somewhere safe, because it's going to be an encryption password for the wallets that are embedded in your node. Again, Igra nodes run a Kaspa node within them, and because they're a base rollup, if you choose to add the RPC services, that front end profile, the second part of our video that's coming here in a few minutes, you're going to need 5 or up to 5 Kaspa wallets that are embedded in your node and ready to process transactions. So you're going to want some sort of wallet password that only you know, so that you can secure these wallets and make sure that if someone randomly gets access to your server, they won't be able to drain those wallets. So I've created one off screen and I'm just going to paste it in here. That's done, but with passwords in terminal, you can't see anything. So I just hit enter. And now it's generating the wallet keys for my 5 workers, 0 through 4. And now it's pulling down Docker images that have been created by the Igra Labs team. And we can see it pulls down a bunch. So the Reth package, which is Rusty Ethereum, it pulls down Kaspa D or Kaspad, as some people say. And that's obviously the Kaspa node. A tool for health checks, and then creates some volumes for these services, and then finally creates the containers, the Docker containers for them. And then we can see that it's waiting 10 seconds for those backend services to initialize, and they've all been started. So setup is basically complete. This backend profile is going to take quite a while to sync, because what it's doing is starting up the Kaspa node and allowing it to sync. And Kaspa nodes typically take 4 to 6 hours to fully sync. So they're going to need to download all the block history, all of the UTXO history. They're going to have to import that UTXO history into the node. So this is a good time for you to kind of take a break if you want to, because you've got a handful of hours until your node is ready for the next step. Now, it does give us a nice warning. Optional, enable transaction submission. That's the part 2 of our video. So we do want to do this, but we don't want to do it now. We want to wait until after the IBD sync, or initial block download sync, happens of that Kaspa node. Now, this script that Igra has created gives you an ability to follow along with that sync progress. So you can just type Y right here for yes and hit enter, and it will show you the progress that you have on that live sync of the Kaspa node. So what I'm going to do at this point is wait until the initial block download is done, and then come back to you and show you what that looks like, and we'll move on to part 2 of actually setting up the RPC services for this node. So just a couple minutes probably for you, handful of hours for me, and we'll be back with part 2. All right, so as our Kaspa node is syncing, I just wanted to give you a view into what that looks like. This terminal right here is on following the logs. So it's showing us, every log that gets hit from this IBD sync, or this initial block download sync. So we can see that, IBD, it's processing block headers. It's at 40%. This feels like it's going fast, but because Kaspa is a UTXO-based chain, you can't get too excited when it shows IBD 100%. Because you're still going to have the UTXO import, and it takes an hour or so, a couple hours for that UTXO import to complete on the Kaspa node. So you can follow along with these logs while you're waiting, and keep an eye on this. But once it's done, you'll start seeing accepted blocks on the Kaspa node logs, and I'll come back and show you what that looks like, so you're safe to move forward in the process. But just a quick note about what this looks like and how you can follow along. We're at 42% there. I still expect I've got 2, 3, maybe 4 hours left of this process as it finishes the block headers and the blocks themselves, and then indexes all of the UTXOs and imports those into the local Kaspa node as well. So keep an eye on this. You don't have to watch too closely. It should be automatic and just run in the background. But it will take, estimated 4 to 6 hours from the completion of part 1 that we just finished, where we finished running the script, until you're able to move on to part two and actually have the node fully running. So just keep an eye on it, or come back every so often, make sure that you're still seeing new logs throw in this terminal window, so you can make sure that it hasn't stalled out or stuck or anything. I've never had any of those issues before. It seems to work perfectly. I've done this 3 or 4 times between Galley on testnet and that test Galley on mainnet, and now the actual mainnet of Igra. So just follow along, keep tabs on kind of what your system's doing, but it should be all self-service and automated in terms of syncing this node. And then we'll come back for part two when this is done. All right, so here we are with a quick update to the syncing of part one of setting up the Igra node backend profile. So you can see here we're now going through UTXO chunks in the terminal. This is what I mentioned earlier about how even though your IBD shows it gets to 100% on block headers, it's not done. So this is normal, and this still will take another hour or so probably. But you're essentially importing UTXO set chunks now, and then it needs to go through actually like indexing those properly to blocks. So this is still basically in progress, still self-service, nothing you need to do here. Just keep an eye on it and know that these UTXO set chunks are normal and part of the sync process. So we'll let it continue and finish with all of the underlying Kaspa node sync, and then we'll come back and do part two, which is setting up the front end profile and the RPC services so that you can actually use this node in wallets or dApps or offer it publicly to others. All right, one more quick update for you here. The terminal is going crazy on the node, and that's normal. That's exactly what we want to see. So it's completed the Kaspa node sync, and now the ATAN layer on Igra is processing and validating all the historical blocks for your node. So for mine, I can see that I'm about 600,000 blocks behind. So it's just going to keep rocketing through these to validate everything and catch up the Igra node itself, since the underlying Kaspa node is fully synced now. And then it'll be correct with the current state of the network, up to date, essentially. So we're just going to let this go. I have a feeling it's another 30 minutes to an hour, something like this. And just to give you a point of reference, when I started recording this video, it was about 2.5 hours ago. So in that time, I got the full Kaspa node synced, all the UTXOs indexed and imported, and now the Igra node is running its validation layer, the ATAN layer, to actually process all those blocks and build the L2 blocks in its history so that you have both the L1 history in the node and all of the Igra L2 history. So I'm going to let this run. I'll come back and show you what it looks like once it's done, and then we'll move on to part two of setting up the front end RPC services. All right, so our Kaspa node and our Igra L2 node are now fully synced, and the part one backend profile setup is 100% done. I was watching these logs and I started seeing the 0 regular transactions, 0 entry, and the signals that it had completed all of the updates. So if we go back to our original terminal here, this is the ending of part one when we finished running the script, and it gave us this information right here on how to enable RPC services. What we're doing right now is finding out what Kaspa wallets, what L1 wallets the node script or node setup script created for us. We need to get those addresses so we can fund those wallets with L1 CAS so they can actually process the transactions and push them to the L1 when our node's RPC receives L2 transactions. All part of the base rollup architecture we briefly touched on earlier in the video. So we're basically just going to follow through these processes that it gives us. We do need to set a change in our environment variable, but I'm gonna pause that and skip that for just a second because I want to load up these wallets first so I can do all of that at the exact same time. So first thing you're gonna do is just copy this command that it gives you and run it. So this is just dot/scripts/debug/wallet-status.sh. And if you're following along or doing this the way I am with an IDE, you can actually check this out and learn a little bit if you're interested. So we can go to scripts, which is that first directory in our command, then debug, which is the second directory or subdirectory in that command, and then the wallet status.sh. You can click into that and you can actually read through the terminal command line or bash shell script, if you will, and see what it's actually running. What it's going to do is essentially find the wallets that are set up for you and display the addresses and their balances. So I'm going to close out of that and just run this command in the terminal. Now it looks like we hit an error with the wallet status script. And I think it's because of the environment variable that we skipped over and not rerunning the backend profile before running this script. So if you run into a similar issue like this, just flick over to the guide and find step 6. You can copy this entire thing, this command right here, and pop it into your terminal and just hit enter. Now this is going to generate new wallet keys and overwrite any previous ones that were done by the setup script. And you're going to have the seed phrase or the mnemonics show on the screen. So I've done this off camera and just skipped showing you guys here. So I'll remove this command from my terminal here. Let me just clear it actually. And what you're going to want to do is go into your environment file. So it's .env, and you're going to need to make some changes. This environment file does have some sensitive information in it to you. It'll show your wallet encryption password that you set up before. So I'm going to show you how to make these changes in the example instead of doing it in my actual env. You'll do it in the .env file for your node. So in the example, if we look through here, it's basically a bunch of configs for the node. And what we're really looking for is like RPC read only. Yeah, right here. So line 67, RPC read only. We want to change that to false. And then I'm on a Mac, so I hit Command S and just save that file, make sure it's there. Again, this is just the example file. I've already made that change in my actual .env file. And then coming back over to the guide here, excuse me, we really just need to pull the latest images using step 7. And those will pull down. And then we can run the front end side of this. And that should allow our script to work. So it's recreating the containers for the RPC providers. And then as soon as that's done, we'll be able to run that wallet script. And those are all healthy. So if you just hit the up arrow in your terminal, you can go through your history. So what I'm going to do is go back to this .scripts/debug/wallet-status.sh and hit enter. And now we see all of our wallet addresses. We can see they have available Sompi, available CAS, pending. Currently, these wallets are completely empty. So what we want to do is take these addresses and fund them with real CAS on the L1. So I'm going to fund those real quick and then come back and run this command again to show you that it changes the available Sompi and available CAS in the script response. And then we'll come back to this env file and finalize part 2. Right, so I've funded these 5 wallets. I put in 100 CAS to each wallet. And I'm back at the terminal here. So what I would like to do now is run that script again to make sure that the balances are what I expect them to be. So I'm just going to go up, run that wallet status again. And now we've got recent transaction history and a balance for each wallet. So Wallet number 4 here has 100 CAS. Wallet number 3 has 100 CAS. Wallet number 2 has 100 CAS. And wallet number 1 has 100 CAS. And then finally, wallet 0, index 0, available CAS 100. So everything is good here. Now you got to pay attention to your default address, because what we need to do is go into our environment variable file. Again, I'm only showing you the example file. You're going to make these changes in your actual env file. So scroll down, starts on line 107. And what you're going to do is take each wallet and copy the address and replace the placeholder that's in that associated wallet. So wallet 0 for index 0, wallet 1 for index 1, to put your correct address in the to address field. And you should see your password that you created earlier in the password for each of these. Now, while I'm doing this, I'll explain why it's important, because you don't want your node to run out of funds. And the way this base rollup for Igra works is that the attestation, or not even the attestation, sorry, the RPC calls that are happening to your node require a Kaspa transaction. One of your 5 wallets here is going to send a transaction on the CAS layer 1 to essentially embed that payload data and make the transaction, available on L1. And the to address, right? We see W2 wallet 2 address. This is where each wallet is sending its transaction. So if you have your own address in here and you've correctly updated these, like we're showing you how to do right now, then you're not going to lose any funds in your node, and you won't have to top up your node wallets all the time. You'll be sending transactions to yourself on the Kaspa L1. So this wallet address is both the from and the to address for your specific node. That way, every time you get an RPC call and you push that transaction to the CAS L1, the CAS you use to facilitate that transaction is coming right back to your wallet. You will have gas fees that you never get back, and that does build up over long periods of time. So depending on how much you fund your wallet with, really tells us how long it's going to last, or how soon you'll have to replenish that wallet. And this is important because it won't be able to process RPC calls unless it's got CAS in there to push those transactions to the L1. So as long as you've got your own address in here, you're going to be losing extremely small amounts of CAS, just the standard, Kaspa gas fee on the L1 network. If you don't have your wallet in here, you'll be losing your entire UTXO that you send. You'll be sending it to somebody else, these placeholder wallets. So this is really critical for you to update. So once you've got that updated, the only thing left in our optional RPC instructions, which are also right here, is set that RPC read-only to false, which we did up here. Our read-only is false. Again, I'm showing you the example file. You'll do this in the .env file, the one that actually powers your node. You can see that I don't have, the cat name that we expected, and that's all just because it's an example. In the env file, I actually do have the proper information that was set up during that script. So make sure you're running against the .env, not any example files. But I'm showing you the example here just to protect my wallet passwords and addresses and things like that. So once we have the env completely updated, the only thing else we need to do is restart these workers, which is just that command right there. So we'll take it down here and we'll pop it in and hit enter. I need to go update my env with the correct wallet addresses. So I'm going to get that updated and then be back to you here in just a second. All right, I'm all set up. I've got my .env file correctly updated. It's got 3 important things. The RPC read-only is set to false. It originates as true by default. So you will have to go into that .env, change it to false. And then you're also looking for W0, W1, W2, W3, W4 to wallet address. And you want to update those with the wallet addresses that you get from running this debug wallet status command in your terminal, which shows us that we've still got our 100 CAS on all of our wallets and we're all good to go. So if we flip back over the guide, all we need to do is restart workers. And you should read this warning. It's what we just went over. That wallet to address in your ENV is the change return address. So you must have it correct. Otherwise, you're going to lose the remaining funds that you funded that wallet with. So from here, we can just go grab this command to restart our workers, paste that in, hit enter. It's going to recreate all of the RPC provider instances, the Docker containers that are running to enable that. And after just a few seconds, you should have a completely running node. We've now completed part 2. So in the beginning, we did part 1 where we set up the foundation node, the backend profile. We allowed the Kaspa node that's embedded to sync fully and complete its initial block download and UTXO import. Then we allowed the Igra node to validate all those blocks and catch up with the current status of the network. Then we came in here and we set up our wallets. We funded those with some CAS, and then we restarted the RPC front-end workers so that we could actually have a functioning RPC node. Now, if you do need to, update or restart your services, all of those commands are right in here. But I want to go through a couple cool ones that I find really interesting. So one, if you just want to see, the logs of everything you're running on this server, grab that Docker compose logs with the flag F, which is follow. So it'll continue showing new ones as they arise. So we'll pop that in and just see what it says. See what actually shows us is running on the server itself. Sometimes these take a long time to actually populate and start showing you the logs. You can always cancel the command if you need to by just hitting Control-C, and it'll just get out of that. If you prefer, you can look at just a specific detail, specific service, right? So this is your Kaspa node and Igra adapter, and copying this in will show you just a select bit of the logs that are running. Hopefully that populates for us quickly. And it looks like it's not, but that's all right. These commands will eventually pop up and show you the logs that are going on if you need to see them. Similarly, you can look at the execution layer or one of the RPC providers, right? You've got 5, 0 through 4. So you can change that 0 to a 1, 2, 3, or 4, and it'll all work exactly the same. So at this point, we've got a functioning Igra mainnet node that also provides RPC endpoints that you can use in a dApp or a wallet or wherever you want to see them. So I will come back and set up a testing on this node and walk you through that. But this video is getting a little long, so we may just make that a separate video entirely. So if you have questions, you can reach out on X. I'm Argon Mining, or in the Igra Labs official Discord, which I'll put a link to in the description of this video. I'll also include links to the public docs for Igra, as well as this GitHub guide for how to run a node. And hopefully it helps you kind of get started sooner rather than later, or a little less painful process in setting it up with a video to walk through and see what's going on for you. So take a look, see if it's helpful. If you got any feedback, I'd love to hear it, and enjoy the rest of your day. Mainnet soon.